Okay, in this problem we have another system of equations that we're going to solve by the addition method, also known as the elimination method. But before we can do that, we have fractions here. And to make life simpler, we're going to first get rid of the fractions by multiplying each equation by the least common denominator, or the least common multiple of all of the denominators. So in the first equation, we have a 4, a 6, and a 3. The smallest number that can be divided by 4, by 6, and by 3 turns out to be 12. In the bottom equation, we have a 2 and a 5. The smallest number that can be divided evenly by both 5 and 2 is 10. So I'm going to write these out over on the side, distributing the 12 to each term in the top equation. 12 times x over 4, 12 times y over 6, and 12 times negative 2 over 3. Alright, so the way we look at it, 12 divided by 4, that's 3. 3 times x is 3x. 12 divided by 6, that's 2. 2 times y is 2y. 12 divided by 3 is 4. 4 times negative 2 is negative 8. Second equation, we are going to multiply everything out by 10. So we have 10 times x over 5 plus 10 times y over 2 equals 10 times 1 over 5. And the 10 divided by 5 is 2, and so we end up with 2x there. 10 divided by 2 is 5, so plus 5y there. 10 divided by 5, that's 2. 2 times 1 is 2, and we end up with 2x plus 5y is 2. Now we have our two equations. We'll line them up. 3x plus 2y equals negative 8. 2x plus 5y equals 2. And we can't add them up just yet. Adding them up doesn't cause any of the variables to be eliminated. So what we're going to have to do is work on one of the two columns, either the x's or the y's. So in order to get the x's to be the same number, we can't just multiply one of the equations. We're going to have to multiply both of the equations. And so we're going to get the smallest number that can be easily divided by both 3 and 2. That's going to be 6. So we'll need to make that 3x into a 6x by multiplying by 2. The denominator, we need to make the 2x into a 6x by multiplying by negative 3. We'll make the 2x into a negative 6x. Alright, so we'll multiply the first equation out. 2 times 3x, 6x. 2 times 2y, 4y. 2 times negative 8, negative 16. Negative 3 times 2x, negative 6x. Negative 3 times 5y, negative 15y. Negative 3 times 2, negative 6. Now, when we add, the x variable is eliminated. We add 4 plus negative 15 is negative 11y, and that's going to equal negative 22. Divide both sides by negative 11, and we get y is equal to 2. Alright, the next thing we're going to do then is we need to plug that y equals 2 into one of our equations. And we'll just pick one. We'll pick the first one handy here, 3x plus 2 times y, which is 2, is equal to negative 8. 3x plus 4 equals negative 8. Subtract 4 on both sides. 3x is equal to negative 12. Divide by 3. X is equal to negative 4. And so the solution to the system of equations is negative 4, comma 2, and we end up with, well, that is our solution to this equation. So there was a lot to do in this particular problem. We had to first multiply by common denominators to get rid of fractions. Then we had to multiply both equations by something to get a matching term in each of the two equations with opposite signs. Add them up, solve for y, plug in, solve for x. Right, that's going to do it for this problem.